Hello there, thank you for joining us today on the Royfit channel. I am Royston, your host, and today we're going to be doing episode 2 of our macronutrients playlist. Now today we're actually going to be talking about carbohydrates, complex forms of carbohydrates, the simple kinds, the daily intake, the types of sugars going from simple to complex, and the health risks that can come with digesting too much of both. Now we're going to start off with saying that basically carbohydrates come in two forms. Now they come in the simple form, such as sugars. Now these are called monosaccharides. I'll go into a bit more depth about these saccharides in a bit. Now they are absorbed into the body and used very quickly. They can pass through the intestine without any need of enzymes breaking them down. They are that small. And because of that, they can go straight into the bloodstream, into the cells and to the brain that need them. Complex carbohydrates are known as disaccharides or polysaccharides. However, they are actually too big to pass through the intestine on their own. So they actually need to be broken down by enzymes. Now these enzymes are called lactase, sucrase and maltase. Because of this extra step of absorption, complex carbs are actually slower released into the bloodstream over longer periods of time. Now obviously both play a very important role in our body's energy system, since they are both our body's main source of energy / first choice. Both are broken down into adenosine triphosphate, or some of you might know it as ATP. Now this is our body's molecular energy currency. Now I'll be making a separate video on this since ATP is such a massive subject on its own. Now both of these carbohydrates, they take different steps to get there, but ultimately they end up being used and stored the same way, and that's as glycogen stores or fat, and then eventually used as ATP. Now a gram of carbohydrates, whether it's simple or complex, has up to 4 calories per gram. You typically need carbohydrates to make up 45 to 65% of your daily intake. That's roughly 1,500 calories out of a 2,300 calorie intake a day. Now our bodies don't need a constant supply, as we do store glycogen, a form of sugar, in our muscles and liver. Enough to last us a day, but we do need to keep our stores topped up. Complex carbs allow us to use their energy without using our stores, since it's slow release from the intestines throughout the day. Now what this means is that we don't have to keep refueling every 4 hours. Now if you just ate simple carbohydrates, you'd find yourself needing to refuel every 2 to 4 hours because your body would just process it so quickly. That's why complex carbs meet our energy demands in such a more efficient way due to the longer release. Now the daily recommended sugar allowance, now this is simple sugars. Now adults should have no more than 30 grams of free sugar a day. Now it's equivalent to roughly 7 sugar cubes. Children aged 7 to 10 should have no more than 24 grams a day, roughly 6 sugar cubes. Children 4 to 6 should have no more than 19, but overall it should not exceed 5% of your total caloric intake for the day. Now your daily complex carbohydrate intake, so your complex sugars, now this is a much larger number than your simple sugars. Your daily intake for these carbohydrates for men is about 252 grams. Now I know it's oddly specific, and for women it's 198 grams. Again, this does depend on your diet and goals. It can be more or less. Now glucose in the blood stimulates the pancreas to release insulin, which then triggers uptake of the glucose by the cells in the body, so this is the muscle cells, causing blood glucose to return to base levels. Now insulin's very important to our health, and I'll go into the effects of insulin resistance towards the end of the video. Now insulin actually turns off fat burning and promotes glucose burning as the body's primary fuel source. Any excess glucose ends up being stored as glycogen in the muscles, and it can be stored as lipid in a fatty tissue. Now, fructose is also taken up into the blood from the gut. Now, this is the second type of monosaccharide. But in this case, the liver serves as a pre-processing organ that can convert fructose into glucose or fat. The liver can release glucose and fat into the blood, or store it as glycogen or fat deposits, which, if sugars are consumed in excess, may lead to fatty liver disease and also increased risk of diabetes and cardiovascular disease. Again, towards the end of the video, I will be going into more depth about these. Now, here are some examples of foods that have simple and complex sugars. Now, as for simple, as you can imagine, these are more or less all going to be processed foods. So you've got your fizzy drinks, your sweets, your cookies, biscuits, pastries and desserts, energy drinks, ice creams, all chocolates, all that kind of stuff. Now, complex carbs are found in whole wheat breads, pastas, flour, brown and wild rices, barley, granola, potatoes, corn, legumes. So these are like black beans, chickpeas and lentils. So above I had briefly mentioned monosaccharides, disaccharides and polysaccharides. Now these are the different types and the different structures that sugar takes. Now, monosaccharides are simple sugars. They're the most common, which is glucose and fructose. Monosaccharides have a formula of CH2 and O. They typically contain 3 to 7 carbon atoms. Now, glucose is 6 carbon and fructose is also a 6 carbon atom sugar. Disaccharides, however, form when two monosaccharides join together. So this is where they start to become more complex. So they actually do this via the dehydration reaction. It's also known as the condensation reaction. Now, in this process, the hydroxyl group of one monosaccharide combines with the hydrogen of another. Now what this does is it releases a molecule of water and it forms a covalent bond known as a glycosidic linkage. So for instance, as you can see in the diagram below, this shows glucose and fructose combining via the dehydration reaction to form sucrose, a disaccharide which is known as table sugar. So as you can see here, we've got our glucose, we've got our fructose, they've come together, a glycidic bond has been formed. Unfortunately it doesn't show the water atom popping off as well, but that should be there. So common disaccharides actually include lactose, maltose and sucrose. Lactose is a disaccharide consisting of glucose and galactose and is found naturally in milk, which is why many people can't actually drink milk. Now it's because of the lactose. Now this is called lactose intolerant. Basically what that means is you don't produce enough of the enzyme called lactase to break this sugar down, so it can cause many stomach upsets. And lastly we come to polysaccharides. Now they are long chains of monosaccharides and disaccharides. Now again they're all linked by glycosidic bonds and can contain different types of monosaccharides and disaccharides. So as you can imagine, this actually makes the molecule weigh quite a bit. And now examples of polysaccharides are starches, glycogen, which is actually what our body creates to store sugar. You've got cellulose, which is used in plant cell walls, and you've got chitin, which is actually used in the exoskeleton of insects. Obviously these are important to these living organisms. Now, starch is stored as a form of sugar in plants and is made up of a mixture of two polysaccharides, amylose and amylectin. Glycogen is the storage form of glucose in humans and other vertebrates, so we're not the only ones that use glucose. Like starch and glycogen is a polymer of glucose, so this basically means it's composed of more than one big molecule. Glycogen is usually stored in the liver and muscles, Whenever blood glucose levels decrease, glycogen is broken down via hydrolysis to release glucose that cells can absorb and use. Now, a hydrolysis reaction basically means, hydro, it just uses water to break these molecules down. Now, the human body doesn't produce all of these sugars. All monosaccharides have to be externally sourced from plants or dietary products from other animals. Now, unless they are produced from disaccharides and polysaccharides in the body. Now, an example of when a human makes their own sugars is when you're not eating, especially overnight or in between meals. The body has its own monosaccharide sugar. The liver supplies stored glucose by turning glycogen, the polysaccharide we mentioned above, into glucose in a process called glycogenesis, or when it creates polysaccharides from existing disaccharides and monosaccharides in a dehydration reaction. Those are the only times our body breaks or makes sugars. Now, as you're aware, you've probably heard this before, sugars can turn into fat. Now, this is a process called de novolipogenesis. Now, that's literally the creation of fat from non-fat sources, which can be a benefit and also a downside to the human body. This process, as I said, turns glucose and fructose into lipids, which are then stored as body fat. However, this process is actually quite inefficient in the body. Now, the process can be upregulated / enhanced if dietary fat is lesser than 10% of your daily intake. Now, this is one of the reasons why sugar, simple or complex, can be bad. Now we're going to go into the negatives of a high sugar intake diet. Now, eating more than the suggested amount of simple sugars for extended durations of time can cause you to develop insulin resistance. Insulin is a hormone that regulates blood sugar via cell uptake. Now, I'm going to make a separate video on insulin because, again, it's another big topic that I can delve into. Now, diabetes type 2 used to be an illness that only affected adults later in life through neglectful diets as they got closer to retirement. It's now not something that only affects adults but also young people from ages of 12 upwards. Now, type 2 diabetes is caused through insulin resistance, so constantly having too much sugar in the bloodstream, your insulin receptors don't become as sensitive, so insulin does not work as well at regulating blood sugar levels. Now, in a world of processed sugars, cheap sugary drinks, cereals, chocolates, etc., we must be careful how much we consume and how much we feed to our children, as this is a growing epidemic that is happening. Again, thank you for joining me today, guys. I really hope that you've all learned something from this video. Don't forget to subscribe, hit like and ring that bell because there are a lot more videos coming your way.